Welcome everyone to NSTA Web Seminars, where you can find live interactive learning at your desktop. Tonight's presentation is titled Connections Between the Practices in the Next Generation Science Standards, Common Core Math, and Common Core English Language Arts. Our presenter this evening is Sarah Michaels. We also have Ted Willard online with us from NSTA to provide information about the Next Generation Science Standards. My name is Bryn Slates. I will be moderating tonight, and Jeff Lehman is online with us to provide technical support. Before we get started, I wanted to remind everyone to visit the NSTA Learning Center, which is your online portal for Teacher PD, and we have over 10,500 resources available in the Learning Center for you to check out. And you'll notice that over 3,600 of those resources are free, which is great. You can add those resources to your My Library area and get to those when it's convenient for you. Our community forums are also available, a great place to connect with other science teachers and discuss the issues that are pertinent to your classroom. We have online advisors who look forward to assisting you in the Learning Center. You can access them by just clicking on the Live Support button. I also wanted to mention our free tools that will help you organize your professional learning, help you keep track of your goals, and then when you're all done, you can document that and show the work that you've done. All of this is available by going to learningcenter.nsta.org, and we welcome you to navigate there. At this point, I'd like to go ahead and introduce today's presenters. Ted Willard is going to get things started with us. He is NSTA's expert on NGSS, and then he will be followed by Sarah Michaels, who is our featured presenter, and she's from Clark University. So at this point, I'm going to go ahead and turn it over to Ted. Welcome, Ted.
Thanks, Bryn. Thanks, everyone, for being here. I know we're going to have a good session this evening. Room filling up quite a bit already. I'm going to give you just a quick overview, make sure we're all in the same place of understanding what's going on with the Next Generation Science Standards, and then let Sarah get into the details about the practices. The standards themselves have had 4 organizations sort of involved in their development: the National Academies of Science, Achieve, NSTA, and the American Association for the Advancement of Science. And there's sort of a multi-step stage here. We have the National Academies, which have put together a framework to work with. That leads to, and that framework came out in July 2011. And then you have the standards themselves being put together. And from those standards, assessments, curricula, instruction, and teacher professional development will all come about. Looking at that first step, what the Academy did in making the framework. The framework has sort of 3 dimensions of the key piece here. There's scientific and engineering practices, and we're going to spend a lot of time talking about that tonight. Cross-cutting concepts, which we will actually be featuring in the rest of our web seminars this school year, and the disciplinary core ideas. If you haven't looked at the framework, I really strongly encourage you to do so. You can get a PDF for free from the National Academies Press, or you can go to the NSTA store and get a copy there. Here are the 8 scientific and engineering practices. For those of you, it was already mentioned, we've had 8 web seminars last fall that went through each one of these, and for those of you interested in gaining some better understanding of any one of them or all of them, I suggest you go back and take a look at that series. And then we have the cross-cutting concepts. And again, we will be featuring those starting 2 weeks from tonight. We'll give you some information about how to register for that before the end of this evening. And then the disciplinary core ideas: life science, physical science, earth and space, engineering, technology. Engineering is something that's new for some people to see here. But each of those topics breaks down into further subtopics. And we can even take it each of those subtopics gets down into even more details. So the framework sort of gave the big picture of what's supposed to happen on all this, and then there's been the development of the standards themselves by a team of writers from across the country, and then a group of 26 states that have been working on the standards, and the whole process being coordinated by an organization called Achieve. If you see that your states there, those of you in blue states are heavily involved in it. But keep in mind that once the standards are completed, and they're expected to be done later this spring, that any state has the option of adopting them. And I know that there are some states in that gray area that are intensely looking into doing so. So here's a little piece of what the standards look like. I'll give you a little sense of them. You have those scientific and engineering practices. You have the disciplinary core ideas. You have the cross-cutting concepts. Those are all together in this color box. It's known as the foundation box. And then up here you have a performance expectation, which is meant to guide, to be, instructions for assessment developers and how they can assess whether students understand these core ideas, these practices, these cross-cutting concepts, and how they all fit together. And so, for example, you can see that develop molecular models to support is part of developing and using models, that this idea of reactants and products and atoms and mass being conserved in a chemical reaction is part of the disciplinary core ideas. And the idea of conservation of mass is a cross-cutting concept. But as I pointed out before, this idea, the performance expectations combine those pieces together and describe what is to be assessed. They are not meant to be that this is what specifically has to go on in a lesson. I think, and Sarah may even comment on this a little bit later, is that to work with a particular core idea and help students gain an understanding of that would involve multiple practices over time, sometimes doing things like asking questions, carrying out an investigation, developing explanations. All those things might happen as you're trying to understand how substances react in chemically characteristic ways. And so with that sort of very opening piece here, I'll pass things on to Sarah and let her share what her ideas are.
Great. Thank you. Thank you both, Ted and Brandon. Welcome to everybody out there. I'm assuming that you can hear me fine. I wish I could see everybody, but this is kind of cool, but kind of weird at the same time. So anyway, my topic is what's common across the Common Core, ELA and math, and the next generation science standards. And to some extent, this question grows out of the fear that some of us have that the NRC framework for K-12 science education and the next gen science standards are kind of coming late to the party. And people wonder if the next generation science standards will take a back seat to the real core. And I've even heard some folks worry that the science exemplar texts that are embedded in the ELA standards might become the primary vehicle for teaching science, which would, in my view, be a complete disaster. But I'm going to argue that if we take seriously what is common across all of these new standards documents, the Common Core and the next generation science standards, then science, and really science teachers, are actually in a position to take the lead, or at least to exert some real leadership in going forward, both in professional development and in working together to support the implementation of all of these new standards in the classroom. So, hope this works. So let me just say a word about who I am. As Bryn said, I'm a professor of education at Clark University in Massachusetts. We're dealing with a big snowstorm, as you guys may know. I'm a sociolinguist by training, and I'm a co-author of Ready, Set, Science, which was the practitioner volume that grew out of taking science to school. And I'm the senior research scholar at the Hyatt Center for Urban Education at Clark. And I'm particularly concerned about issues of diversity and equity and access for students, but also for teachers. I'm really concerned about making sure that all teachers get the support they need to really bring this new vision of science into their classrooms so that it really penetrates the classroom walls or doors. So here's my plan for the next hour. First, as the title suggests, I'm going to talk about what's common across all of these documents in math, ELA, and science. And I'm going to argue that at the core of all of these standards is evidence-based reasoning or reasoning practices. And I'm going to argue further that this is going to bring about a need for a much, much greater emphasis on discussion and well-guided talk, what some folks call academically productive talk or discourse-intensive pedagogy. And it's going to require a pretty radical shift in classroom practice, in my view, across all three disciplines. Second, I'm going to talk about what this shift from recitation to reasoning looks like in practice. And here we'll look together at some videos of what this new vision, what these new practices emphasizing talk actually looks like in action, in science. And then third, I'm going to ask, what is the research evidence that focusing on well-guided discussion will actually produce the kind of robust learning that we're calling for? And then last, I'm going to talk about what's needed if teachers are going to rise to the challenge that these new standards entail. And here I'm going to talk both about the challenges that we face and also some of the newest developments and resources that are already available. So let's get started. Okay, so what's common? All of the standards, math, ELA, and science, require that teachers focus more attention on core disciplinary practices. Ted sort of talked about this. These are intellectual practices that are central to each discipline. And as Ted said, for anyone who's been attending these webinars, you have already heard quite a bit about them. You may have even memorized this list of 8. So here are the science and engineering practices. I'm not going to read through them. You've already seen them. But I'll give you just a minute to look over them. And here are the mathematical practices. These are a little bit different. They're framed a little bit differently. Make sense of problems and persevere in solving them. Reason abstractly and quantitatively, construct viable arguments and critique the reasoning of others, model with mathematics. There's some resonances across these. Use appropriate tools strategically, attend to precision, look for and make use of structure, look for and express regularity in repeated reasoning. And here are the ELA. Okay, so instead of practices, the ELA standards identify what they talk about, you can't see it very well, capacities of the literate individual. This is actually page 7 from the Common Core State Standards for English Language Arts and Literacy. The literate individual builds strong content knowledge, just listing them, some of them. The literate individual values evidence, comprehends as well as critiques. So here's a listing of all of these practices, the key intellectual practices in math, science, and ELA. They're all different, as you would expect, but there are some striking commonalities. And so I want to take a look at some of the shared elements across the standards documents. And in some cases, they're pretty much identical. Okay, so take a look at math practice number 3, construct viable arguments and critique the reasoning of others, and science and engineering practice number 7, engaging in argument from evidence. And a few more of these practices seem to relate explicitly to sense-making and discussion, reasoning, in the service of arguments and explanations. So I want to take a look at where we can see discursive or talk-related or discussion-related elements, okay? So here in the math practices, all of these in red relate at some level to making sense, talk, critiquing reasoning, expressing reasoning, making arguments, and so on. And similarly in science, there are a number of what we might think of as discursive practices that relate to talk or discussion or communicating one's ideas. So what about ELA? Okay, are the same discursive practices common here as well? So as I said, the ELA standards emphasize the capacities of literate individuals and key processes of communication. And if you read the small print, what I've got in yellow there, if you read the small print, Here in the ELA standards, you see that they're, in many cases, word for word the same as in the mathematics and science documents. So you get construct effective arguments, or assess the soundness of reasoning, cite specific evidence, worry about the validity of reasoning, relevancy and sufficiency of the evidence. So from a separate listing of these practices, you can see that at the core of the Common Core and Next Generation Science Standards is what I would say building arguments with evidence and reasoning. And this, I want to give a little shout out to Tina Chuk and Oki Lee. This Venn diagram, you guys can take it. It's a very slight adaptation of one they developed. These are folks at the Understanding Language Project at Stanford University. And I think it really helps you see what's at the core of the core. And so what is at the core is reasoning with evidence, building arguments and critiquing the arguments of others, and participating in reasoning-oriented practices with others. But I want to take a deeper look at the practices that have been identified. Okay, even the ones that don't mention anything at all having to do with talk or discussion or argument. So, for example, if we look at practices 2 and 3 from science, developing and using models, or planning and carrying out investigations, or if we look at practices 4 and 5 in math, model with mathematics, use appropriate tools strategically. So in order to learn how to model or analyze data or use appropriate tools, kids have to participate in these practices with others, and it's primarily through talk that this happens. These high-level thinking practices, every single one of them, require that students participate in making their thinking public and cogent. And for this to happen, teachers are going to have to find ways to help all students. And I'm talking about English language learners and language minority students, struggling students, kids on IEPs, all students go public with their ideas. They're going to have to help students externalize their thinking, listen carefully to one another, and actually really take one another seriously. They're going to have to help all kids dig deeper into the data and evidence and models for their positions, and they're going to have to help kids work with or attend to or engage with the reasoning of others. They're going to have to build a classroom culture where students think with each other, construct arguments with data and models, critique the thinking of their peers, and make progress collectively on important problems. And these reasoning practices have to be enacted. And for learners, most are enacted socially, in the beginning at least, through talk and writing. So in order to participate in these thinking practices, you have to be enacted into them socially. And by social here, I'm not just talking about student-led group work. This is really important. Well-structured social interaction, well-guided talk, builds in time to think as an individual, time for productive struggle, with scaffolded support for new ways with words, new ways of representing ideas and modeling, making thinking public and available to each and every learner. So in my view, we're going to have to shift our view of what's at the core, what's common across these standards, and see that really what's common to the Common Core and Next Generation Science Standards is actually building classroom cultures that support public reasoning, making thinking visible and available. And so teacher-guided discussion, productive talk, is going to have to become the new normal, really the grounding for all of the practices. So here's my bottom line. Because these thinking practices are inextricably linked to content and to core ideas, participating in talk is not an add-on. It's really going to turn out to be fundamental to the learning goals in each set of standards. And so from my point of view, what's common is more than a few key practices at that very center of the Venn diagram. well-guided, scaffolded reasoning, talk, and discussion is going to have to become the new foundation, the new bottom, the new sort of norm, basically, for all of the practices in the Common Core and next generation science standards. And in my view, this is not going to be trivial. If we're serious about promoting the thinking practices at the heart of each of these standards, we're really going to need a huge change, a dramatic change. I think of it sort of as a sea change in terms of the kind of talk that teachers facilitate. And here the research is really clear. And this is the bad news part of my talk. This kind of discussion is not happening in most classrooms, even in ELA classrooms. So while there's a lot of talk going on, it's often not productive talk. We know, for example, from Donna Alverman's work, that many teachers say and actually think they're doing discussion when they're not. And in Appleby's large-scale study of middle and secondary classrooms, he and his colleagues found that there's an average of less than 2 minutes of discussion per hour in most ELA and social studies classrooms. And what little there was consistently in high-tracked classrooms, leaving out a lot of kids. So it turns out, while there's lots and lots of talk in classrooms, there's actually very little well-guided discussion happening at any level, at any grade level, in any subject area in the country. Instead, teachers rely on what we might think of as recitation and a few reliable talkers. Most of the so-called group discussion is actually more like group recitation, and that's where, the teacher asks a question. It's usually a question that has one right answer that the teacher is looking for. A student responds, usually with a pretty short answer, and then the teacher evaluates, like, good, right, or not quite. Anyone else have an idea? And then eventually the teacher gets the right answer and then goes on to another question. And people call this very familiar sequence the IRE, initiation, response, evaluation. Teacher initiates, typically, student responds, and the teacher evaluates. Now, I want to be clear, there's nothing fundamentally wrong with the IRE. In fact, it's actually a really good way to review or check or quiz the kids about what they recall from an earlier lesson. But here's the bad news. This IRE, or recitation and direct instruction, really the dominant forms of talk that you find, do not support reasoning. They don't support the building of arguments with evidence, and they do not support students to do the heavy lifting of explaining or critiquing or building common ground with one another. In the IRE, the students are positioned kind of as getting the right answer or the wrong answer. They're not doing the heavy lifting. They're not positioned as thinkers and as builders of arguments who weigh evidence and so on. And so, as I said at the outset, the challenge facing the country now with the Common Core and Next Generation Science Standards is to shift from recitation to reasoning-based discussion. So let's stop for a minute and talk about what this actually is, what productive talk actually looks like and sounds like in science. What does it look like when you're making thinking visible and when the kids are doing the heavy lifting? So a lot of folks think that the goal is to get the teacher to step out of the way, to stop talking and let the kids talk. And that's actually not my view. So I'm going to show a video of some fourth graders. This is part of a web-based video case that explores just that. This is a screenshot from this website that explores just this question: what is productive talk in science? But to give you a little bit of context, I'm going to first play a sort of overview or introductory clip, which is also on the web. It's available to anyone at any time for free, which is really cool. And then after this introductory clip, I'll play a clip from a fourth grade classroom. Both of these videos come from a really interesting website called the Inquiry Project, and you can see the URL at the top of the screen. So the Inquiry Project has a full-blown science curriculum for grades 3 through 5 on matter, which helps kids build over 3 years a sound understanding of matter and material in which the physical quantities of weight and volume and density are interrelated, and where kids come to recognize that solids, liquids, and gases are distinct forms of matter. It's really building towards an understanding of the particulate nature of matter. And the curriculum was funded by NSF. It uses a learning progression approach integrating math and science with a focus on evidence-based reasoning practices through investigation and discussion. I had nothing to do with this curriculum. I think it's a very strong one. What's really interesting is that the entire curriculum is on the web with teacher's guides, student notebooks, assessment probes, all available for free. But this website also has a component called Talk Science, and I actually did have something to do with this part of it. The Talk Science component has lots and lots of resources that help teachers who are using the curriculum in grades 3 through 5 to go more deeply into the science they're teaching, but also it helps them develop their skill at orchestrating productive science discussions. And in just a second, Bryn is going to bring us all to the website and we'll view the videos. If you were doing this yourself, you would go to the, I'm just going to show you how you would get there. You would go to the home page, click on PD for Teachers, and then as you mouse over that, you don't click on it, you see this library of resources, and that takes you to lots and lots of interesting videos. And they emphasize this issue that I've been talking about, productive talk. And the video that we're going to play first is called, you can see that little icon, What is Productive Talk? And if you were using these resources yourself, you would have access to a bunch of short discussions between a sociolinguist who will remain unnamed and an urban teacher talking about the characteristics that they see in the video clip. But we don't need to listen to those. We can talk about this video ourselves. And so now that's where those little clips of conversation about the video are. So now Bryn is going to push out this video, take us to the website, and we can watch it together. This is just the overview video.
Okay, thanks, Sarah. And just to give everyone an idea of what's going to happen here, I'm going to basically push out this video. It'll open in your browser, so whatever browser you have currently open for the internet, it'll come to the front of the screen, and then you'll just need to click the play button to start the video. We will give you enough time to watch it, and we'll give a little bit of additional seconds for those who may have a little bit of a slower connection speed. When you're done watching the video, you'll come back and you'll give a green check on your poll buttons to let us know that you're finished. And I'll just let everyone know it does depend on your own computer's connection speed and the software that you have installed. So if there is something that isn't working, just bookmark the link and then you can check it out later. So I will also post it in the chat window. All right, everyone, here it comes. And don't forget to click play.
Okay, so yeah, so I'm going to now, we're going to watch the classroom video, but you know, we think that it's so obvious when you show a video that everyone is going to see what they're supposed to see, but I actually think that that's not typically the case. And so I'm going to give a very quick preview of what you're going to see in this clip that's coming up, okay? So the teacher begins with the question on the table. What makes the water level rise when you put in an object that sinks? Is it weight or volume? And she reminds the kids to look at each other and really listen. And then the first kid to talk is Matthias. And he's really, really unclear. He actually talks for over a minute, and he basically says something that's pretty interesting, pretty complex. He says that his group figured out that it had to be volume because when the two cubes with the same volume went in the water level, which he calls volume, rose to the same height. So from that he concludes that it can't be weight because they weighed different amounts. And if it were weight, the levels would have been different. He's quite inarticulate and he's hard to follow, but he's actually reasoning with evidence-based counterfactuals. It's actually pretty amazing. And then Flavor agrees with Matthias and proposes a thought experiment involving an eraser and a big cup of water. It's kind of a form of model-based reasoning. And then the teacher asks Javon to repeat what Flavor said and to repeat his reasoning as well. And then a girl, Alicia, disagrees with Flavor, challenging an assumption about the setup of his thought experiment. And another girl, Aisha, poses a question to Flavor, and then Flavor responds to the question. So with that little preview, let's now watch the video.
Okay,
now,
thanks, Sarah. Go ahead.
Yeah, so now you go back to where it says on the right, number 2, classroom video, classroom discussion. Is that right? And we just click on that?
So I'm going to push out the direct link to this video, so all that everyone will need to do is click play. And I'll just remind everyone, you know, if it's not opening for you, the first thing is if it doesn't open to the front of your screen, click on the link that I put in the chat window. If that doesn't work for you, these video links will be included in the web seminar collection, so you'll be able to check them out later. This is just a 3-minute clip here, and so just appreciate your patience if it is not able to work for you, but it looks like it is for most folks, so here we go with the second video. And just remember to click the play button.
Okay, so are we back? Good.
We're getting there.
So should I wait a few more seconds, or do you think I should start?
Sarah, it looks like most folks have completed watching the video, so I think you're safe to go ahead and move on.
Okay, all right. So I hope that worked and you could see the video, but like Bryn said, this is online. You can access it at any time. So the thing is that in the video that we just saw, it looks pretty easy, or at least to some people it might look easy. You know, there's nothing to it. You just ask a good question and it works. Kids talk, they learn science. But to others it might look very difficult and confusing, and in fact, in my opinion, it is difficult. There are lots of challenges, lots of obstacles. And if we were together, we'd probably view this video again, perhaps with a copy of the transcript, which is actually on the website. You can download it. And we'd have a real discussion about it. Like, you know, I would ask, what do you notice? What characteristics do you see? What do you notice about the students? What do you notice about the teacher? But instead, we can't do that. So we thought we would do a poll instead. We'll take advantage of the polling characteristics of this blackboard and ask what one or two characteristics that were identified are most striking to you in the video. I mean, it's an example of all of the characteristics, but what stand out? And there's also an other option. Did we not get them right? Or are you noticing something that we didn't mention? So what one or two characteristics are most striking to you? And so, Bryn, will you now make the polling open?
Yes, I just opened up the screen marking tool so folks can select that clip art, which, if you weren't here for the introduction, is the bottom button on the toolbar, which is right alongside of your participants window. And just a note to everyone, try to keep your stamps below the words here so we can continue to see our labels. I know it's tough with so many stamps, but folks are doing a pretty good job. It looks like we've got those all over the place, Sarah. They're noticing lots of different characteristics here.
Yeah, which it makes sense, but there are, I think, some that are getting more hits than others. So it looks to me like connecting one's thoughts to others, listening, which is really interesting because that's the opposite of talking, and then questioning and clarifying. So some people, actually I really like this, in the other, you can write, somebody said a culture of trust, which I think is really interesting, and somebody else agrees. So if people are seeing other characteristics and you want to actually write it out, that would be terrific. Aha, this is actually kind of cool. So explaining and participating are kind of gaining some traction, but I still think that what people are most struck by are 1, 3, and 4. And then people mention the teacher as facilitator might be a characteristic, politeness, interest in subject area, considering they're 4th graders. Respect, somebody wrote, which I think is related to this culture of trust. Sitting in a circle, yeah. So this is very cool. I've never done anything quite like this. And I want to let everybody get their 2 cents in it. Connecting the data they collected, yeah, to their reasoning. Ah, very interesting. Interest, I can't, it's hard, it is a little bit tricky in this other. We should have had, Bryn, we should have had a bigger space for 7. But I'll tell you.
But they can also type there in the chat. If you're running out of room, folks, feel free to type in the chat window. Yeah,
so somebody wrote validating. I wish I could say more about that. I would really love to be able to have a discussion. That what they're seeing as characteristic is that kids are either validating one another's ideas, I'm not sure, using academic language, interesting, validating the, it's hard to say, the purpose, validating the purpose of the investigation. Very, very small class size, yeah, that's true. Okay, we could spend a lot of time on this, but I actually want to take another poll now. This is going to be a shifting of gears, okay? What scientific practices, remember those 8 that we talked about at the beginning, they're listed here. What scientific practices are evident in this clip? And here, you can pick as many as you see evidence of. Before I wanted you to restrict yourself to just 1 or 2. But here, go for it.
Okay, everybody, those clip art is active again, so go ahead and stamp. It looks like they're pouring in, Sarah.
I know. Oh my goodness, this is very interesting. Yeah, try to keep your stamps from covering up the words if you can. All right, so some of them, okay, a couple things are interesting to me. People are seeing, not everybody, but some people are mentioning each and every one. Darn, I can't see the words anymore. But there are also some that are more in play than others. So asking questions, constructing explanations, analyzing or interpreting data, engaging in argument from evidence. Anyway, this is pretty fascinating, and I think this is a big aha for me anyway. This is a 3-minute clip of 4th graders, and I think one of the worries that a lot of us have is that people will see these practices as isolated. You know, on Monday we ask questions. What's going on here? That's interesting. And on Tuesday we plan investigations. Wednesday we might work on modeling or analyzing data. So the point here is that these are clusters. They may not all be in play at any 1 minute, but in this 3-minute clip, we see evidence actually of all 8 practices, which is pretty interesting. So I'm going to move on. We could, again, I'd love to hear people's, I really, really wish we could talk back and forth, but I'm going to move on to get some questions out there. So Bryn, do you want to take over here?
Sure. I've just got a couple of reminders to give everybody before we jump into our Q&A. And folks, you can see those here. If you missed the opportunity to turn off notifications, just follow the steps there. Also wanted to remind you about resizing your chat panel. And of course, we are going to continue the discussion in the NSTA Learning Center community forums. We do encourage you to check those out, and I'll put the link there in the chat window. This goes directly to our NGSS forum. So at this point, I'll go ahead and turn it over to Ted, who has maybe seen some questions that have come in. If you have a new question now, go ahead and type that in, and Ted will pull out a handful of questions for us to present to Sarah now.
Sorry. So Sarah, I'm waiting for some folks to post some questions in the chat window. I'll start with one. I mean, I don't know if you know the background of the, you worked personally or know who worked with the teacher within this classroom, but would you like to sort of talk about how this teacher moved into this sort of practice within her classroom?
Yeah, it's a really good question. So all of the talk science related videos were filmed in a school in Roxbury, in Boston. And it was a school where there was tremendous leadership on the part of the principal and a real ethos among the teachers around valuing students' ideas. So there was a lot happening. And then in particular, when we worked with several of the teachers to do the science curriculum, there was a real interest on the part of the teachers to learn to get better at promoting productive talk. So I actually worked with this teacher over the entire unit. It was about 18 lessons. and would watch the lessons, and then we would debrief afterwards. And what's amazing is we have a record of 18 lessons with the same kids and the same teacher. And this lesson was a fair ways into it. I think it was lesson 12. And you could see over time, somebody commented that it takes time to build this kind of talk culture. It doesn't happen by itself. And I was actually able to watch the teacher build norms, and you could see it happening day by day. So in fact, it was in this lesson, number 12, that she said, look at each other and talk to, you heard it. She said, who do you disagree with? Tell him. And the kids just took to it like ducks to water. So this, you're kind of seeing something fairly new. The kids were not sitting in a circle beforehand. They were not talking to each other in this way. But the teacher, over several days of emphasizing the importance of listening hard to one another, and who thinks they understand what so-and-so just said, and who can put it into their own words. She was actually using talk moves and tools that we had worked on with her, and that now, in a sense, the Talk Science website shows everyone. She was working with talk moves and tools that really helped her establish this kind of very focused culture. The kids really, they had developed a kind of communicative stamina. You could see it happening day by day. So I don't want to give people the idea that there was nothing to this, but it also didn't take very long to build this kind of culture. She was very focused and very consistent and very committed, but we could see it kind of growing day by day.
And that ties into so that piece here that Kim Kelly has raised. And she asked a little bit about doing this as a whole class versus having students engage in a think and pair in groups of 2 or 3, and working through that. And I'm guessing here from what you just said there that there's an importance in the role the teacher plays at this. Is there a point within this where students can do this on their own, or is the teacher always playing a role as a facilitator in this approach?
Yeah, it's another really important, good question. So this curriculum is set up like many, where there is kind of a whole group ask the question, get started, and talk about what we think or what we know and what we predict might happen, and then break into small groups and work in groups typically of 2 or 4, and carry out the investigation, and then bring back to the circle, to the whole group, the results of your investigation and make sense out of it together. And so you were seeing the make meaning discussion after the kids had worked together. Now, very often during the whole group discussion, the teachers that we worked with in the school would use a turn and talk. So often in the midst of a question that came up, sometimes it would be a question that a kid raised or a comment, she would say, turn to the person next to you and talk for a minute. Very short, 30 seconds. Sometimes she would say, at the beginning of the discussions, she would frame a question and then she'd say, stop and write down some things. So there would be moments interspersed in this group discussion for either a turn and talk or a stop and jot. But she also, during the discussions, was facilitating by asking questions like, what do you think about that idea? Do you agree or disagree, and why? Or who thinks they understood and can put his idea in their own words? Or can you say more about that? Or, so let me see if I'm understanding what you're saying. Are you saying, and then checking back to make sure she had heard. So the teacher was very active in the discussion, and over time, the kids began to take on. So it happened one day, I remember, somebody said, I'm not sure I completely understood what you said. Could you try it again? And we sort of looked, the teacher and I looked at each other, and we knew that that culture had sort of taken hold. And then the kids did begin to say, I want to add on to something that he just said, or spontaneously, I disagree with you because in our group we found X. So yes, the kids began to take on those moves of building on one another's ideas or challenging, and then you could see it happening in their small groups. But in this work, it started in the whole group that the teacher supported the development of this kind of talk by facilitating it with very particular talk moves. And actually that's a big part of what the Talk Science website provides you videos about. We can talk a little bit about that later.
Great. Well, why don't we go on to the next section here, and we'll do some more questions at the end.
Yes, there will be more time. Okay. So here's now, we've seen this guided productive talk. It's foundational. It's the core, et cetera, et cetera. It sounds great, and yet it's actually really, really difficult, really challenging. There are lots and lots of obstacles. So when I talk about this with people, with teachers, and I have a wonderful colleague, Kathy O'Connor, and she and I have worked on this together. When we talk with teachers, they express concerns, and overwhelmingly the first concern we hear is we don't have time. It takes time to do this kind of discussion. But they say things also like, what if no one talks? Or I don't want to put them on the spot, you know. They might be ELs or have language-related problems. He's too shy, that kind of concern. Some teachers talk about a fear of behavior. What if the kids are disrespectful or if they get unruly? Here's a really common one. What if Spencer just hogs the floor as usual? I mean, we all have Spencers, even in my graduate classes. What if we get totally off track? That is a huge, huge concern. Or here's another. What if they bring up content that I don't know what to do with? It's a big concern for elementary teachers in science. And while some teachers are able to figure this out on their own, and there are really some naturals, there are teachers, in fact, I want to say something. We learned about this talk work from teachers. We didn't invent it. We actually, for years and years and years, worked with some amazing teachers, Kathy O'Connor and I, and we really have tried to talk about, write about, share with others what we learned from these teachers. So some teachers can do this on their own, and other teachers find it really, really challenging and scary. And the bad news here is that teachers are not well prepared from their own experiences in school to do this kind of academically productive, reasoning-oriented facilitating of discussions. They typically rely on group work, thinking that they can kind of offload the talk onto the group work activities, onto these hands-on activities, and that will teach the kids what they need to know. And we have not found that to be the case. So that's also a problem. And there's more bad news, okay? Even in really good NSF-funded science curricula, where the curriculum itself makes a space for these making meaning discussions, teachers often have a really hard time running them. In fact, this was what prompted the Talk Science grant that was developed to help teachers using the inquiry curriculum. So we find that even though there's a place in the curriculum for these discussions, they're often skipped. We hear often we just didn't have time. The activities took too long. But there is some good news, and this is what I want to emphasize. Based on recent research and development efforts, okay, it turns out that these reasoning practices are common to all three sets of standards, and so you get a really big bang for the buck because the practices of discussion transfer from one content domain to another, and they transfer by being carried both by kids and teachers. And then in addition, we know a lot now about how to induct students from all backgrounds into these reasoning practices through rigorous, rich, teacher-guided discussions. We know a lot more about how to sort of make this happen and take hold. We've made significant progress in helping teachers orchestrate discussion and writing activities in the service of what I think of as making thinking visible and available to all kids. In fact, I feel like we've sort of made something of a breakthrough in the last few years, and it gives me real excitement that we're able to help teachers in ways that we haven't been able to before. And I'm going to talk a little bit about that. But before I do, I want to ask about the research. Okay, what does the research say? Do well-guided talk and discussion really, really support learning? Because it's going to take time and effort, lots of professional development to make this shift from recitation to reasoning. And so it really is important for us to ask, will it pay off in terms of student learning? And so in what follows, I'm going to very quickly report on some interesting research on the impact of well-guided discussion in math, in ELA, and in science. So first I'm going to start with math. This is from work called Project Challenge. It was a mathematics intervention in Chelsea, Mass. And the purpose was to provide challenging mathematics education for upper elementary and middle school kids in Chelsea, which was at the time the lowest performing district in Massachusetts. You can see on the slide 70% of the kids qualified for free lunch. Over 60% spoke languages other than English at home. So the intervention was multifaceted. There was math every day. They used good reform curriculum, Turk investigations, and so on. They had in-service professional development in math, et cetera, and they did this consistent use of productive talk with frequent discussions. And the teachers in this work felt that this was the single biggest factor in the success of the program, this focus on talk. Okay, so what were the results? Well, in each cohort of 100 kids at the end of 2.5 years, the class average on the California Achievement Test math portion was at the 90th percentile of the national norm sample, okay? And at the end of 3 years, over 80% of each Project Challenge kid cohorts, classes, scored advanced or proficient on the MCAS, and that's the Massachusetts high stakes test, and the state average at the time was 38%. So this is in the lowest performing district in the state, and they just had really remarkable results. And there were comparable gains in English language arts. They don't know how this came about because there were no interventions in the English language arts curriculum. Very, very interesting. Okay, the next example comes from Community School 134 in the South Bronx. In 2003, the teachers at this school began implementing an approach to reading comprehension that drew on the principles of academically productive talk, they called it accountable talk, to scaffold students' deep engagement with challenging reading texts. The school adopted the junior grade books curriculum and this discussion practice called shared inquiry as the heart of the school's language arts program. And the specific focus of the intervention and the teacher professional development was on helping kids learn to discuss really challenging text, to weigh evidence, and to explicate text-based arguments, so reasoning. So this school in the South Bronx had a student population that is 99.8 free lunch eligible. And aside from promoting discussion and reasoning, okay, that was a huge part of this, but the more immediate goal in this school was to raise test scores. Before the intervention, over 70% of the kids were below or far below standards. That's the way they talk about it in New York. And after implementing this program, Shared Inquiry, for only 6 months, the test scores in the school rose dramatically, and then the gains were maintained during the second year of the intervention and 2 years following. And unexpectedly, the standardized scores in math, the test scores in math, rose equally dramatically. Again, don't know exactly how that happened. The most important thing to note about this rise in test scores is that the kids were moving out of levels 1 and 2, far below and below basics or below standards, and into levels 3 and 4. And the history of test score rise in high poverty schools is that you can move kids from failing to needs improvement, or from below standards, from far below to below standards, but it's much, much, much harder to get kids out of level 2 and into proficient or meet standards or exceed standards. And after only 6 months, the school went from over 70% below basic to over 50% meeting or exceeds standards. So another very interesting result. Okay, now I'm going to turn to science. So this comes from the UK. Adie and Shayer, these two researchers and curriculum developers, have been involved in research called cognitive acceleration that spans like 20 years. They've been doing it in a variety of domains, but in science in particular is what I want to talk about. And in each of the areas that they work, they create curriculum and practices that have 3 features in common. First, they emphasize rich, well-designed problems that challenge students' thinking, that require modeling and explanation. Second, they emphasize building understanding through discussion. This is this talk piece, debate and critique. And then third, the programs encourage metacognition. They engage kids at the end of each lesson in sort of reflecting on how they figured out the answers they arrived at. The teacher at the end of each lesson says something like, "Hey guys, I didn't tell you the answer you came up with today, so how did you figure it out?" And they actually replay the process by which they reasoned through these problems. So the results have been really, really staggering. When middle school kids participated for 2 consecutive years in this program, this is the science program, and this was every other week for just 18 sessions, they performed significantly better than the control groups on their British National Achievement Tests in Science, taken 3 years after the end of the program. That's the top graph, the science. And you know, you could say, okay, the intervention was in science, so that makes sense, but they also showed large differences in math and English on their national exam scores 3 years later. So this body of work demonstrates that productive discussion, this notion of well-structured or well-guided talk, produces robust learning. And some people talk about it now, and they say that it actually helps build the mind with long-term benefits for thinking and achievement, which show up in standardized tests and transfer to other content domains and persist over years. Very, very interesting. Now, these are not the only studies that show this kind of dramatic learning. And I've put together a very brief text that includes citations to these, but also a number of other studies. And Bryn, you're going to help us now. She's going to push out this text if you want to download it quickly. And then I want to now move on and talk about some of the new developments.
Okay, Sarah, let me just quickly push that out to everyone. And you should now
push this out, and then I'll continue.
Window come up, and you can save that to your computer.
And then I'm going to just continue on. Okay. So here's the good news part. From research over the past decade, we've identified a set of very learnable and useful tools that help teachers do this kind of academically productive talk. And I'm not going to have time to go through all I could about these tools, these talk moves and talk formats in detail, and explore with you why they work. But again, the Talk Science website can be very, very helpful. But it is important to note that these tools work in all subject areas and at all grade levels, literally from pre-K through graduate school. And there are now a number of really good PD resources that are widely accessible, easy to implement, and pretty low cost in ELA, math, and science, okay? So that's great. Now, we could take a little bit of time for some questions if you'd like, or I could just quickly talk through what's now available, and then we could answer.
Why don't you go ahead and go through your pieces, and then we'll try to take some questions.
Okay, I promise you we will come back. All right. So now I'm going to talk about and even demonstrate a little bit some of the work that different people have been doing. I just got a thing about the text anyway. Work that different people have been doing to get past those obstacles that I mentioned earlier, leading productive discussions, and they have three common elements, all of these new programs. There's a basic focus on goals for discussion, some basic talk tools, and then there's an emphasis on building, this was what kind of came out in people's comments, building this culture of trust, building norms that support respectful and equitable discussion. So what's new about these approaches? Well, in the past, we've told teachers to ask higher order questions. All of you guys have heard this, use Bloom's taxonomy. Don't ask known answer questions, which cannot possibly, that can't be right. Or step to the side and just get the students to talk to one another. That's what we have said in the past to get this to happen. And it turns out that none of these rules of thumb is at the right level for teachers on the fly, in action. What they need are moment-to-moment tools or moves to help students externalize their thinking, go public with their ideas, clarify and extend their own reasoning, and build on and critique the thinking of others. So here's where I think we've made a breakthrough. We've created some scalable, cost-effective, visible ways to make these talk tools accessible and usable. And that's pretty exciting. So the state-of-the-art PD with teachers now incorporates three elements. A shared simple set of goals for thinking about discussion and these discussion tools, talk moves. The second is challenging, coherent content. That's critical for getting these discussions to work and take hold. And then the third is collections of classroom videos with real teachers and real kids demonstrating extended talk in relevant content areas. And here are some examples where these talk tools are integrated into content domains. I'm not going to have time to talk about each of them. The URLs to each of these programs is on this screen. I'm actually only going to talk about two of them today. It's interesting that these are all quite different. They work in different ways. Some require live facilitation, these PD approaches. Some don't. Some embed PD in specific curriculum lessons with just-in-time support for teachers. Some don't. Some cost money, some are free. But all of the programs provide effective support for teachers in learning these new discussion practices. And like I said, there's a big bang for the buck, because if you work on talk in language arts, it transfers to math or science. So I'm going to talk about two very briefly. The first one is based around a book called Classroom Discussions. It's a study group text. This is math. And it's used with a facilitator's guide, Classroom Discussions, Seeing Math Discourse in Action. And it's a multimedia professional learning resource with guidelines, discussion questions, handouts for the study group, and 5 hours of video examples with examples of kids doing this kind of math talk. I think actually this book, Classroom Discussions, I should have a little thing here. This book is really the best book available for people who are interested in learning about talk. Okay. Each video clip stands alone. There's no commentary. Remember the one that we played from the Talk Science? There was kind of voiceover commentary. This, you just have the videos, but they're accompanied with all these other resources. So it's a complete package, again, used in a study group where the teachers are reading this book, Classroom Discussions. All right, the second one is what I've been talking about. It's Talk Science. It's a web-based PD site, and that's where we've seen the videos from. So I'm just going to tell you a tiny bit about this. So it provides a professional development study group pathway. Yeah, there you see it. Linked to the curriculum. It's kind of modeled on the Rosetta Stone. It guides participants to engage with videos in sequence that help them establish classroom norms. Here's a whole sort of video case on building this culture of trust that people were noticing. It introduces them to talk moves. It provides classroom cases, also scientist cases, helping them understand the science that they're teaching. And the Talk Science PD is kind of a blend of web-based study, face-to-face study group meetings, and then opportunities to try this stuff out in the classroom. And the Talk Science portion is designed for study groups with video and text resources, but no live facilitator. So this is interesting. It's web-based and it's free. And there's no live facilitator. A lot of the expertise is built in. And you can see video cases on productive talk. This was the first one that we looked at. And this is really interesting, this business about talk moves. There's a whole set of videos that lay out different talk moves with commentary, and you can see different teachers using them in different ways in different classrooms. So I encourage people to go and take a look at that. This talk moves overview I was going to play, but it's 6 minutes, and so you guys, if you're interested, you should go and play it, see for yourself what it's. You know, one thing I want to say, let me go back to this slide. You know, these resources are aligned with a curriculum for grades 3 through 5. Well, great. But what if your school isn't using that curriculum? Or what if you're a middle school science teacher or a high school science teacher? So in this site, the Talk Science resources are there for people independent of the curriculum. There's really a set of professional learning resources and cases that can be used at any grade level in any science domain. In fact, they're actually higher ed faculty using these videos of little kids with their graduate TAs to help them facilitate more productive discussions with undergraduates. So even though it's linked to a curriculum, I think these resources can be used widely across the grade levels. So now I want to leave these resources and bounce up a level and talk about the fact that, in my view, focusing on productive talk, focusing teachers on talk in any domain, so this could be ELA, math, or science, is what folks talk about as a high leverage practice. And that's because in order to facilitate a productive discussion, a teacher has to think deeply about the disciplinary content. You cannot do this independent of disciplinary content. The teacher has to think about the learning goals of that lesson and performance expectations, which tie directly into the next generation science standards. But they also have to think about the demands and affordances of the particular task or problem at hand, and they've got to pay attention to their students as learners. They've got to focus on what their kids know or might think they know or might need to know. So at the outset, I argued that at the core of all the new standards, ELA, math, and now science, are core practices which necessitate well-guided group discussion. And I want to also suggest that science may be the place, the area, to take the lead in helping teachers facilitate this kind of reasoning-based discussion. So why? Why would science be in the best position to take the lead? So one reason is equity. Okay? Good science teaching focuses on shared theorizable situations, right? This builds equity in from the start. It's not a matter of how much you've learned at home or how many museums you've been to on the weekends. It's about how you reason with what's right here, the shared problem spaces that we open up in the classroom. So I keep saying to people, no one is a native speaker of physics. So the equity issue is a really good one. Second, there's buy-in. Typically with science, it's like the best place to maximize the likelihood of having a good discussion because everyone is already invested in how the world works and brings really well-developed theories and extensive embodied knowledge of the physical world. So you get these really interesting discussions. And of course, the world speaks back, right? You can't ignore the evidence. Authority is in the world, the evidence, not in the text or the teacher. So the last reason is resources. We now, in my view, have better tools and resources that are accessible, for free on the web in science, better than they have in math or ELA to support teacher development of these thinking practices. Now, there is the problem of curriculum, right? Nationally, we have this problem. There's plenty of science curricula and kits out there, but the problem is that they're long on activity and short on thinking and sort of, as a result, short on learning. But in my view, if teachers use these talk tools to support evidence-based discussions, then the curriculum, the textbook, the kits that they already have can become effective sites for reasoning and learning for both kids and teachers. Last, I don't know if you will agree with me on this one, but we have the chance to put discussion at the center. We have the chance to establish these talk practices at the center of science teaching and learning instead of as an add-on. When teachers learn these new practices in science, they'll carry them with them into other subject domains. This is particularly important in elementary. So they will carry them into other domains just like the kids carry them into other domains. And as opposed to math and ELA, we kind of have the chance to start fresh. Because of the pressures of No Child Left Behind, there's actually been very little teaching of science at the elementary level, at least in my experience. So rather than fearing that science is coming late to this party, I think we should see ourselves as in a position to take the lead. And that's my closing. Let's go for it. Let's take some real leadership here. Thank you.
Thank you, Sarah. What if we look here? Let me go through a few things here, and we'll do the survey, and then we'll take some questions after that to go through.
Great. I'm sticking around.
So I just want to point out for folks where they can find some information here about the Next Generation Science Standards and all the other resources that NSTA has available. Here's our homepage, nst.org, and you can always find an image up here in the right-hand corner that tells you where to look. And that will take you to our page. You can also go directly to it with just nsta.org/NGSS. And that's kept very well to date. We've mentioned a couple times we have a community forum specifically devoted to the Next Generation Science Standards. It's a great place for you to take the discussion. We've had some really lively discussions tonight into that area, so you can continue to talk with the folks who've been engaged here. Two pieces. We've talked about the framework. To mention, NSTA has a reader's guide to the framework as well that you can make use of. The text for that's available free online as well. We've also, in our various journals, had through the last year or so a number of articles about the framework and the standards. I want to make sure everyone knows San Antonio, Texas, April 11th through 14th, right after the standards are released is what we're expecting. It'll be the place to learn about NGSS.
Ted?
Yes.
Could could I say one thing? And Bryn, you're probably going to shoot me, but I forgot to mention the 2 text resources. Maybe after you're done, Bryn can tell people that there are 2 texts that that I've brought with me as well. Sorry.
Absolutely.
I will do that, Sarah.
Excuse me. So we're starting up 2 weeks from today, February 19th, with a web seminar on patterns, the first of our series of 7 on the cross-cutting concepts. We've got those are available now to register for, and I think if you could send out the link where people could find that registration, that would be good. We will also, NSTA is going to be offering 2 short courses. These are not single-shot web seminars. These are a set of a 3-week period where there's both web seminars and other asynchronous work to work on. The registration for that is mentioned down here. We'll also send you the links for that. Our first one is going to be on formative assessments with Paige Keeley. Talk about that. Well, person who I find really provides some valuable insights. And then sticking maybe on a Massachusetts theme, we'll also be having one on engineering by Christine Cunningham from the Museum of Science at Boston, and also is engaged in engineering as elementary curriculum. And with that in mind, thank you all again. I'll pass things on to Bryn after thanking Sarah very much. Met my high expectations as always.
Thank you very much. It's a pleasure.
Thanks, Ted. Thanks, and thank you so much, Sarah, for your presentation tonight. Everyone, let's use that emoticon button. That's the one with the face to give Sarah and Ted a round of applause. And at this point, I will go ahead and push out those additional files that Sarah mentioned. You'll be prompted to save those to your computer. One is Classroom Discussions Chapter 2. The other is the Talk Science Primer. So you'll see those windows come up right now. We would like to thank the sponsor of today's web seminar, the Carnegie Corporation of New York. And a thank you to the administration of NSTA for their support for web seminars. Also, I'd like to show you a little bit about the upcoming calendar. On the 13th, you can join us for Engineering Design Process on the Moon Educator Guide. And on the 14th, Newton's Laws of Motion, Lunar Nautics. Then next week, we have Linear Equations, NASA Connect, Breaking Barriers. And it's all available by going to learningcenter.nsta.org/webseminars. Thank you, everyone, for your participation tonight, and we look forward to seeing you again on another web seminar.